Hello everyone, I am Sainath. Today we are going to discuss the topic about behind classical search. You know this what is behind classical search? This topic is somewhat similar to the topic which we are already covered in previously. The topic name was solving problem by searches. This topic is somewhat similar to the topic only, but little bit different from the topic. Okay, we will discuss about like what this behind classical search tell. Like whenever we are speaking about the behind classical search, we will mainly focus on the local search algorithms. Like what is local search algorithm, what this local search algorithm will do. Like what this local search algorithm will do is, um, instead of finding the solution, it wants to be the solution to be optimum. The main goal of this local search algorithm is to be to make the solution as much as optimal. That is the main goal of this local search algorithm. Like instead of it is not the main focus to solve the problem. The main focus is to be to optimize the solution. That is the main thing here. Okay. Like whenever we are speaking about the local search algorithm, there are many types of local search algorithm is there. For example, hill climbing algorithm and that simulated annealing algorithm and genetic algorithm. These are the few types of local searches algorithm. Like first we will discuss about the first step, that is hill climbing algorithm. Like what it will do means, whenever we are standing at one node, okay, what it will do means it will always find to the compared to this node, like what are the neighbor node, if some node is somewhat better than this node, it will go for that path. Okay, like it is always moves towards the better state. It will simply compare to the present state to the another state. The next state will be is to be better than this current state, then it will simply move to the next state. Okay, but it will step during the local optimum. What is my local optimum? It is nothing but, whenever we are standing at one node, it will simply check its neighbor. It will simply check its neighbor state. Okay, so if all the neighbor state is to be comparatively lesser than the current state, means it will stay at like current node is the optimal solution, but it will lead to wrong it will lead to the wrong problem. Okay, so in this way, it will step. This is the meaning of local optima, and this is somewhat brief description about or that hill claiming algorithm. Next we will talking about the simulator annealing. In this algorithm, what it will do means, it will firstly avoid the local optima. Okay, then we can move for the somewhat better solution to reach our goal. Okay, and also it is gradually reducing the randomness of moving to reach the goal. So it will give us a good solution to reach the goal and the solution to be optimal in this stage. Okay, next we will come into the topic of genetic algorithm. Like what genetic algorithm will do means, it is completely based on the evolutionary process. And like in the genetic algorithm, it uses some techniques, for example like mutation technique and crossover technique. These are the techniques is used to reach the optimal state to reach our goal. These are the somewhat few types of the local search algorithm. Next we will come into the local search in continuous spaces. Like what it will do means, this local search in continuous spaces, it take one technique, the technique called as descent gradient descent. By using this technique, it will always give us a optimal solution to reach our goal. That is somewhat it is somewhat like moreover the solution is to be optimal only. Okay, this is some description about local search in continuous spaces. Next we will come into the searches in non-deterministic action. Like whenever we are speaking in searches in non-deterministic action means, like our whenever like in our AI model, the environment is to be undeterministic, means whatever the outcome we get, that is uncertain. We are not fully believe on this outcome, because our environment cannot have the complete information about that problem. Okay, so whatever the outcome we can get by using that information, that is most probably it is wrong only. So for that reason, our agent will do like multiple steps. It will take multiple possible outcome. By taking all the possible outcome, the agent make the decision. That decision we can somewhat able to acceptable. Okay, this is somewhat description about searches in non-deterministic action. Next we will come into the topic of searching with partial observation. you know like whenever our agent will capture complete information or complete observation from the environment. Okay, so at the time, whatever the outcome we are getting from our agent, it is moreover predictable and moreover accurate. Okay, but whenever we are taking the information partially from the environment about that particular problem, uh, the outcome we know that it is uncertain, that is not that much correct. What it will do means the information is incomplete. Okay, so it will simply take his previous experience or whatever the information is gathered previously. Based on that, it will make a decision. Okay. And also, suppose if the environment is completely new to the AI model, what it will do means, like, our model is compatible to learn according to the situation. Like, even though there is no information about that environment previously, like, our AI agent or model, it will learn from the new environment, and it will modify the information like inside it. Okay, so that is the main thing about the unknown environment. What it will do means the agent must capable of exploring the environment to discover unknown state, unknown path and obstacles. Like, after gathering the information of the unknown environment, it will have some idea like what this environment will take. So so we can conclude that, like, our AI model will also be capable to exploring the unknown environment. Okay, so this is the brief description about this topic. Okay, thank you, bye bye.